Hello friends, in this video we're going to solve this problem of vector calculus, mathematical physics. So here Laplacian del square, this is Laplacian operator, Laplacian del square of 1 by r mod of r vector. So when we say r vector, that means xi cap plus yj cap plus zk cap. So Laplacian operator when operates on 1 by mod of r, that gives 0. Okay, we need to prove this. So now let me show you how to prove this one. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. So now let's start. And one more thing, if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. That's my Insta ID. So follow me on Insta. Now let's start. So what is the question here? So this is the question. This is what we need to prove. Okay. So now you see, let me show you how to prove this. So r vector, that means xi cap plus yj cap plus z k cap, right? So that's why mod of r, or simply you can say r, that's going to be the magnitude of this vector. That means x square plus y square, root over x square plus y square plus z square. So we can write this as like this way: x plus y plus z whole to the power half. We can write this way. The square root means power half, right? So when we say 1 by mod of r, that means it's reciprocal. That's gonna be x square plus y square plus z square. Its power gonna be minus half, right? So when we take reciprocal, that's gonna be minus half, right? Minus half, right? So now del square of 1 by r vector mod of r vector, that means here you see del 2 x2 plus del 2 del y2 plus del 2 del z2. This is the Laplace operator that operates on this vector 1 by mod of r vector. That means 1 by mod of r vector means this one. Okay, so that means we're gonna take the second order partial derivative with respect to x of this, that is x square plus y square plus z square whole to the power minus half. Similarly, plus we're going to take the second order partial derivative with respect to y of the same thing, this, and plus second order partial derivative with respect to z of that 1 by mod r. This is 1 by mod r. Okay, so this is nothing but 1 by mod r, right? Hope you have understood this. So now let us evaluate these values one by one. Okay, so let it be equation number 1. So it will be better if I write the plus sign here. Okay, just give me a second. Okay, let me write this one here so that you can understand better. Okay, so let it be equation number 1. Okay, so or you can write this way. Let me write this one here. Just give me a second. Just wait a second. So let me write this one here. Just wait. Right. Okay, let me write it properly so that you can understand better. Okay, so now here you see this is equation number 1. Okay, this is equation number 1. So let me adjust it here. Okay, so this is equation number 1. Now let me evaluate this 3 one by one. So let me copy one term so that I can differentiate it with respect to x partially. Okay, now let me copy this. Let me take a new slide. First let me find this one. Now you see how to find this. First let us differentiate this term, that first let us differentiate partially with respect to x. Then what you're gonna have? Then you're gonna have that consider this one as x to the power minus half. Then if you apply ddx of x to the power minus half, that's going to be equal to minus half x to the power minus half minus 1. So that's going to be minus half x to the power minus 3 by 2, right? So here minus half, instead of x, here we have x square plus y square plus z square. So x square plus y square plus z square whole to the power minus 3 by 2. Now this is not x, so here it is function of function. Again we need to differentiate this term which is within bracket. So if you differentiate this term which is within bracket, x square plus y square plus z square, then what you gonna have? As we are differentiating partially with respect to x, so that's why we're gonna take y and z as constant. If you take that way, then what you're gonna have? Now let me clean this a little bit. Okay, just give me a second. Okay, now let me clean these things. Now if you differentiate this, then what you're gonna have? You're gonna have twice x, right? Derivative of x squared, that's gonna be twice x. So we're gonna have minus half x square plus y square plus z square whole to the power minus 3 by 2 twice x, right? And 2 cancels here, 2 cancels, so we're gonna end up getting minus x square plus y square plus z square minus 3 by 2 into x. That's what we're gonna have. Now if we differentiate this again with respect to x, that means, let me tell you, if we find the second order derivative of this, that means we need to differentiate this again, this term, right? We need to differentiate this again, right? That means this is nothing but del x of this part, right? Del x of this. So if you need differentiate a second order derivative, then you have to differentiate it again. Okay, so that is what we are doing. This is equal to this one, and derivative of this is equal to this. That's already we have got, right? Now let us differentiate it again. Then what we're gonna have? So in order to differentiate it, what we're gonna do here, we have to consider this is as u, this one as v, right? So that means we're gonna use this product rule, derivative of u into v, that is derivative of u into v plus u into derivative of v. If we apply that, then what we're gonna have? Then first consider this one as u. If you differentiate this again, then what you're gonna have? Minus 3 by 2, then x square plus y square plus z square, z square, again minus 3 by 2 minus 1, that's gonna be minus 5 by 2, that's gonna be minus 5 by 2. Again if you differentiate this, there is already x. Now if you differentiate this term which is within bracket, then again you're gonna get one more x, so that's why it's gonna be x square, right? Hope you have understood. There is already one x, and if you differentiate the term which is within bracket, then again you're gonna get twice x. So if you multiply these two, right, then you're gonna get 2x square, right? Hope you have understood this. Now this is nothing but u, derivative of u into v. Now we need to find u derivative of v, right? So now let me cut this, let me write this one here. We are here we are applying the product rule. So again plus, now take this one as u, this one as v. Now u into v, u is here minus, let me copy this, this is u, right? And v is this x. If you differentiate this, you're gonna get 1, right? So that's it. Hope you have understood this. Now let me clean this. So here you can see these 2 and this 2 cancels, so we're gonna have minus minus plus 3 x square plus y square plus z square. It can be written this way, to the power half whole to the power minus 5, right? We can write this way. Okay, minus 5 by 2 is the power, so we can write this way, half into minus 5 by 2, again minus 5, again minus 5 by 2, right? Now plus on the other side, here this minus this plus, that's going to be minus, right? Minus, again this also can be written as x square plus y square plus z square to the power half whole to the power minus 3. We can write this way. And sorry, I missed this x square, there must be a x square here. So now you see, we know this is equal to nothing but mod of r. This is nothing but mod of r, or simply you can write r. So let me replace it by r, because r vector is equal to x square plus y square plus z square, right? Sorry, not that one, sorry, x I cap plus y z cap plus z k cap, right? So mod of r, or simply r, that's going to be equal to root over x square plus y square plus z square, which means x square plus y square plus z square whole to the power half. So we have replaced this by r, right? Hope you have understood this. So we can write 3r to the power minus 5 into x square minus r to the power minus 3. Now you see, when we differentiated this is nothing but you know, second order derivative of, this is nothing but second order derivative of, sorry, 1 by mod of r, right? This is 1 by mod of r, right? Hope you have understood this. So let me write this one here. Okay, this is what we have got. So when you differentiated this with respect to x, you are getting x square here. So what if you differentiate this you know, with respect to y, 1 by mod r, if you differentiate this with respect to y, then you should get 3 into r to the power minus 5. Then instead of x square, now you're gonna get y square, then minus r to the power minus 3. So now similarly we can find the second order partial derivative of 1 by mod r with respect to z. So now let me copy these two results and let me go to a new slide. Let me copy these two results. Okay, so this one is the first result and the next one is this. This is the next one. Simply similarly we can find, you don't need to show all this system, okay, just you can write similarly, and just you can write the result observing the pattern of the result, 1 by mod of r. So here we have z, so now we 3 r to the power minus 5, now we're gonna have z square minus r to the power minus 3, right? Hope you have understood this. Now let us use this result in equation number 1. Let me go back to the previous slide here. So let me put this result here. This is nothing but you know, del 2 del x2 of mod of r, right? Similarly this is also del 2 del y2 1 by mod of r, right? So similarly this one also del 2 del z 1 by mod of r, right? So we're gonna put the results that we have obtained now in place of these three, okay, terms, right? So now you see, so just give me a second. Okay, using these results in equation number 1, so this is nothing but you know, Laplacian of mod 1 by mod of r is equal to this one plus this one plus this one, right? So now let me take this is as equation number 1, this is equation number 1, okay? So now if we use this result in equation number 1, let us use these three results in equation number 1 using, just give me a second, using these results in equation number 1. Let me write using these results in equation number 1. What we're going to have, del square 1 by mod of r, 1 by mod of r is equal to 3r to the power minus 5 x square minus r to the power minus 3 plus 3r to the power minus 5 into y square minus r to the power minus 3, and plus 3r to the power minus 5 z square minus r to the power minus 3. So now here you see we can take 3r to the power minus 5, 3r to the power minus 5, 3r to the power minus 5 common, 3r to the power minus 5 common. So here we're gonna have x square plus y square plus z square, then minus r to the power minus 3 minus r to the power minus 3 minus r to the power minus 3 minus 3 r to the power minus 3, then 3 r to the power minus 5, and you can write this x square plus y square plus z square as whole to the power half then square, right? You can write this way. Okay, then again 2 cancels, it's gonna give you x square plus y square plus z square. So hope you have understood what I have done. Let me explain it again. So what I have done here, you see, you can write this term in this way. Just give me a second. You can write this term in this way. If you give here power half, then you can write whole square, right? If you cancel these two, again you're gonna get the same term. So the reason behind writing this way, because you see this part is nothing but mod of r. This is nothing but mod of r or simply r, because r is equal to, or mod of r or r is nothing but root over x square plus y square plus z square, which means x square plus y square plus z square whole to the power half, right? So we can replace this by r, right? So let us replace this by r. Then what we're gonna get? R. So as there is the square, so we're gonna get r square here, r square minus r to the power minus 3. So 3 minus r to the power minus 3. Now you see, if you multiply this one and this one, then you're gonna get 3 r to the power minus 5 plus 2, that's gonna be minus 3, then again minus 3 r to the power minus 3, which is equal to 0. That is what we needed to prove, right? Hope you have understood this. So thank you for watching. See you in the next video. Bye bye.